And of course, interactive logon is also permitted with this attack. And after successfully logging onto the victim with this credential, all the system will register any operation of the that has taken place during the hijacker session as the hijacked one. So this is how it looks like. So we can see that we are authenticated in this case as the guest account. We are using we are querying up the privileges of the guest one, and we can see that we are only member in this case of the guest local group membership. But we can write on a protected folder, which is in this case system32. So we have privileges, administrator privileges, but there is a stealthy access when querying up these privileges by using NetUser and AllUser Manager. So to understand the magic behind this, I will briefly explain how the Windows logon process works. So yeah, I know, I told you that I am not that good at Paint. Well, I think that the Windows architecture related to the security is similar to the security concept of some buildings I have been on. So you introduce yourself by giving your name or presenting your identification. A tough guy verify if you have any access permitted to that. And if they check in their database if you are permitted to get into the building. In this case, it's a building. And after that, they will provide you an access token, which will permit you to get into the zones you are allowed to. So for these purposes, this will be our administrator. This will be our main character, which is an unprivileged account, which is also, in this case, the guest account. This will be the Windows security, the tough guy, and this will be the representation of Windows system, which I think that is related, like it is like the system has inside of it, and it's like an RFID system, you know, because you use like an access token, and you can get inside with that card. So to keep it simple, I have drawn 3 floors to represent the privileges a user can get. I know there are a lot more, but it's hard to draw them all. So depending on configuration, guest users can't access or can access only to the first floor. And admin users can move everywhere inside the building. So this is a more technical overview of the Windows security architecture. Here are some authentication packages like Kerberos. And even the KDC server is mentioned here, but the RD hijacking attack is focused on the local users' logon authentication. So we will ignore by now all the domain logon-related objects, such as Kerberos authentication and Active Directory services. So in a nutshell, the logon is this. I think that many of you have seen this graphic before. So when a user authenticates, in this case, the administrator one, authenticates through winlogon LSASS, verify his credentials, and creates an access token. And LSASS will create an access token to identify its security context by using a connection with the security reference monitor, which is a kernel process mode, which is in charge of creating the access token and verifying this access token with the access control list of the files. So it is this process is done by using security identifiers. The security identifiers are the way that Windows has to identify security principles such as users, groups, or computers. So the first part, which is marked in yellow, is the one which differentiates of the machine or domain among others. But the last one, which is we are focused on, is the relative identifier that can be the same across all machines. As you may know, the relative identifier associated with the administrator account is the 500. OK, so let's suppose that the administrator wants to log on, so he provides its username and password to winlogon. To do that, Windows need to initialize some task and connection between processes. And right after we log on, we'll call logon UI to grab the entered credentials. In this case, it uses the auth UI credential provider, but could be another word different if another type of authentication is attempted. With this info, WinLogon creates a WinLogon SID. And this SID will be added to the access token if the logon attempt succeeds. So there are a lot of authentication packages. The most common are MSB1O and Kerberos. We'll be focused on MSB1. The WinLogon, after that, sends the authentication package to, which is the combination of username and hashed password with the recently created logon SID, and then the critical step of the RID hijacking attack, the MSB1 sends the user and password combination to the SAM server, which retrieves the related security info, including the user security identity. And now, to sum it up, the MSB1 checks the info retrieved. If it is OK, it is generated another identifier, and will send back the logon information to LSASS, including the new identifier, which is called LUID. All this data will be used by the SRM to define the security context. So we will see that in short. And after that, we'll continue with the process of the authorization. So it is done by using an access token. So the access token is used to define the security context of a process. This object is created, as I've told you, by the security reference monitor for every user session. So meaning that every child process will inherit a copy of this of the creator one. Every process within a user session will be executed within the same access token. So continue with the authorization task. LSASS will receive the logon information for MSB1O and will check it up against its own database, which is the security registry Hive, to determine if the user allowed access. This check is done by using the security identifier obtained from the SAM. So LSASS, after that, will add the groups, SIDs, and privileges related to the token. And later, WinLogon formally will create the primary access token by calling user init and stuff to initialize everything. Then LSASS provide the access token to the user session and allowing him to the access. OK, so now we can get to the VIP zone and move around inside the building. Yeah, that's it. So now we are going to, now that we went through the Windows standard logon process, let's take a look about the thing that we are interested in. So where in the process are something exploitable? So here's a quick question. How is the user identified by the system after being successfully authenticated? It is done by its security identifier, or security, it's about its own relative identifier, which is unique in the host. How does the system associate a username with his SID? Of course, it's using, we'll see that in short, is black magic. So this is the thing that I have reversed using the IDAPro that Orphis told us about. And let me show you how does it work. So remember this part of the authentication process? You might not know it now, but here is the exact moment when the username is translated to its SID. And then we can see that we are retrieving some important information from the SAM. So how is the user associated with the SID, and what security info is retrieved? The SAM server knows how to translate from username to password. So he queries up this specific registry key. And we can see here that here are, let me see. Yeah. Here are the usernames that are stored in this working machine. After that, in each of these registry keys, there is a rec binary, which is stored as the type attribute the hexadecimal version of the relative identifier. Yeah, we can see it here. In this case, where it is 3E9, which is in decimal base like 1001. After that, some server will look for the key associated with the RID in this specific RID, in this specific registry hive, and it will query all the information which is stored in that place. And the SAM server will retrieve and return this information all in a package to the MSB1 to continue with the authorization process. So why does the SAM stores only the RID? Because the first part of the SID it will remain consistent among all the different security principles in the same workstation, and it is not needed to store all or store them all. So what info is retrieved from the SAM? It is retrieved the password hash, which is ciphered with the system boot key, as you may know, the account status, which is active or no, some additional account restrictions, and a copy of the user's RID, which is the pivotal one, which is the core of the RID hijacking attack. The thing is that I have found that this RID copy is used later by the by the security reference monitor to create the new access token. So to exemplify the attack, let's authenticate with the guest account. But now we will omit some parts of the authentication process. Okay, so the MSB1 sends a guest and the hashed version of the password. The SAM server after that will query up about the related RID of the guest user. It will retrieve the 1F5, which is the hexadecimal version of the 501 RID. And based on that information, it will query again the SAM based on the hexadecimal version of the RID. And it will grab the information, the security information stored in the SAM. And after that, the SAM server will return this information to the MSB1 DLL. So for the guest account, it will happen that it will not be possible for the guest account to authenticate again the machine, which in many cases is disabled. So we will get an access denied. Then in the second one scenario, supposing that for some reason the guest account can authenticate against the machine, she receives her access token, and then she doesn't get kicked out, but has access only to the guest floor. So how could we improve her situation? So it's a mystery. It's not a mystery for us right now to understand that this RID copy is the one which is used for generating the access token. So if we modify it, maybe it will be possible to create an access token, a privileged access token, but we can authenticate with the guest account credentials. So let's modify it. We will replace the 1F5 for 1F4, which is the representation of the administrator RID. So let's repeat the process. So guest account and combination, the guest account and password will be sent to the SAM server. The user, the guest number, the guest name will be sent to the SAM. After that, it will be retrieved the 1F5 hexadecimal version of the RID. Based on that, the HQLM, the SAM server will query again the SAM server, the SAM registry hive, and it will retrieve all the security information related, but based in this case with this RID copy, which is the 1F4. And the login process will continue. So now the MSB1 package will check for restrictions of the user obtained from the SAM security data. The thing is that MSB1 will take the status of the guest account, but will assume that they are from the administrator. So it will the access, even if the administrator account is disabled in this case. So as I have told you, the only thing that is changed is the RID, not the other security properties. So the hash will be the same, and it will be a profit. So password will be the same, and it will be possible for us to log on. So now that everything is OK, the authentication package, it will retrieve the logon information to the LSASS, and then the primary access token will be created. But it will be created by using the RID copy we have modified. So this is the simple way to elucidate the concept of the RID hijacking. So all the security properties related to the account will remain the same, but the RID will be modified. So in this case, getting the RID at the exact moment, it's equal to acquiring the privileges of the spoofed account in this case. And it's possible to do everything as you want. The guest will receive for access token, and it will be possible to hang around in every place inside the building. So this attack takes advantage of some security issues, mainly related to the integrity. I have found that some server does not check if the RID associated with the user is consistent with this RID copy we are modifying. The LSASS does not corroborate the RID with the username right before creating the access token. And the LSASS never looks for RID inconsistencies during the user session. So this is the fun part. I hope it will work. So this is the easy structure of the demonstration. As I've told you, I am planning to demonstrate this by using the Metasploit module I have developed, Windows 10 victim machine, which I have updated early this morning. And we'll try to authenticate by using the guest account, and one which is called unprivileged one, which is not any different than from standard user account. So let's get into it. Let me see. Yeah. Here we go. Yeah. Great. So we need an interpreter session to execute this attack because this is a persistence technique. So this will be our Windows machine or Windows victim. Let me authenticate. There you go. So this will be the IP address. You can see it here. Let's check the system info. Yeah. Windows 10. And this is the latest hotfix. So, net users. These are the current active user, which is the administrator building account. We'll try it with the guest account, but remember that this attack is also reliable on even with standard user accounts. So let's try to authenticate against this machine. This is the IP address of the attacker. So yeah, I have to comment. I will be using the PSExec version provided by Impacket. So it will be not possible for us to authenticate by using the guest account credentials. Let's try to authenticate interactively. OK, not possible for us right now. Let me see something. Yeah, that's the error. But let's try to do it again by using the RID hijacking attack. So this is a Metasploit module I have developed. It is quite easy to use. The first option is it will try to get system to modify the proper binary stored in the registry. The guest account boolean will define if we are going to use the guest account as the attacker one. The password field will define if we plan to set a new password to this hijacker account. And the RID will be the value that we are planning to set. So in this case, we will be spoofing the administrator account. So let's set get system true. Pretty simple. Now we have modified the RID from 501 to 500 in just that. So if we try to authenticate right now by using the psexec command, also with the same credential we have set, we have a connection error. That's great. So let me see. Let's try to authenticate here. It will be possible to authenticate interactively. Oh, yeah, that's why. That's why, yeah. So, as you may know, the in-packet version of psexec will try to acquire system privileges. So in this case, we are authority system, and we are authenticating with the guest account and credentials. So if we check out about in this case, we have started interactive session, we can see that we are guest in this case. You can see it. If we query up the access token, we'll see the interesting thing, which is here. So you can see that we are guest, but our primary access token was created with the 500 RID. So let me see something. So yeah, if we query the guest account, we can see that in this case it's activated, but the administrator one is disabled. We are spoofing the administrator account. We can see that the account is disabled, but for the system, it is, I mean, you are authenticated with the guest account, you are spoofing the administrator account, but the administrator account is disabled. So if an administrator checks their logs, it will be an inconsistency when doing that. So let's try to do it by using net user guest. We can see that it is only on the guest membership, only on the local group membership. I mean, it is on the local group guest. It is enabled. And let's query again the administrator one, net user administrator. Yeah, it is disabled. You can see it here. So well, by now, there is no existing patch to protect Windows from this attack. The only way to defend a machine against this is by detection. I have tested it again with many antivirus, but it is not detected at the moment. I mean, it is possible to detect this sort of attack, which is automatized by the Meterpreter session. But as I told you, this can be done only by using OS resources. So the monitoring of workstation is more complicated on big Windows domains. Since a Windows simple workstation can have this, and it can be used as an open door to pivot inside a network. So yeah, that's it. I hope you enjoyed this attack, and thank you very much.
Do we have any questions? Okay, I'm going to pass the mic here, and then I'm going to run around with the mic runner.
Does this work against the Enterprise edition of Windows with all the special bells and whistles and virtualization techniques?
Yeah, this works on. Yeah. Thank you.
Any other questions?
It doesn't work on domain controllers at this moment, but I'm working on that.
Thanks for a great talk. Have you had any conversations with Microsoft? Like, is this not possible to fix, or why is it still?
Well, you know, the first thing I did was writing to Microsoft, and as you may know, they didn't reply to me. Who knows? Maybe they think that this is not a vulnerability. I think that it's possible to Microsoft to patch this by modifying the DLLs which are related to the local users' authentication. But there is no patch available right now. I have no idea if they are planning to close it. Okay.
Well, that's just an interesting. Do you have any more questions? Okay, right behind, front of you.
Epic. Okay, so if I'm understanding this right, you're able to bypass, let's say, Credential Guard and any kind of protection that Microsoft puts into the enterprise modules, right?
Yeah.
And it works on servers and domain joined computers as well. So we're more or less pretty much fucked.
I wouldn't use that word, but
okay. But you do know sharing is caring, so we're looking for the payload. When will it be available?
Yeah, well, no, the payload is right now available. You can enter it in your Metasploit module. Actually, it is. I have released it in December of last year. Okay, so you can use it, and please let me know if it works pretty well.
Do you have any more questions? Otherwise, I have one question for me. I mean, lately it's not only you. There's been a lot of like responsible and irresponsible disclosure of vulnerabilities lately. But it seems to me like we're getting back a bit to the 90s, where vendors don't actually reply even to research until it's published. Do you agree with that? Or?
No, I haven't. I mean, I'm sorry, I didn't understand you. What did you say?
In general, in security research and vulnerability research, it seems like, how do you think Microsoft should have responded, or are you happy with their response?
Sorry. Well, the thing is that, you know, they tend to, I mean, I find this like a really high vulnerability, you know, but I think that they should provide any response to every people which is emailing them to show you that, yeah, they are fucked up, but I think that it will be, in this case, we should focus on developing, I don't know, it's like, it's my first vulnerability sent to Microsoft, so I don't know which is the proper way to deal with this. But I think it should, I expected a response, a reply, but that's why I have sent this to Black Hat and they accept it, but, well, who knows?
Okay, thank you very much.